Behind me, you can see curved llama land on Arbitrum. We'd like to show off how easy it is to use Titanoboa to launch our own meme coin market here, but we don't actually want to launch one. So we're going to fork Arbitrum and launch it onto this forked instance. It's time to fork around and find out. Every market that you see on curved llama land, whether mainnet, Arbitrum, or any other deployment since this video has come, have all been derived from this one-way lending factory contract. So this contract is pretty cool. We definitely recommend that you take a look at the GitHub repository, read through it. If you'd like to develop against curved llama land, you could just deploy this contract to your local development environment or perhaps deploy it to a testnet. But now that it's already been deployed to all the relevant blockchains, it's probably just easier to simply fork those blockchains and work against that. We saw that when we were doing our Brownie tutorial. We saw that in our Ape tutorial. And Boa also makes it very easy to work against a forked copy of the mainnet. With this and every single unit going forward, we're going to include a pair of Jupyter notebooks. There will be the unsolved version, which will look more like the video here. It's going to have comments where you should enter code yourself. And there's going to be a solved copy where if you actually just run it and execute it, it should work properly. And you'll see output very similar to the output that's in here by default. This saves us a lot of issues like having to retype all this from scratch. We're just going to focus on the relevant commands that are new within these videos. So for this case, we're importing Boa. We're importing SNECMate, just like the previous unit. And for our sake, we've stored some API keys in our local environment variables. We're just storing them in a .env file, and we're using the python-dotenv to load them. This is optional. If you'd like to store it this way, then you should run pip install python-dotenv and set up your .env environment variables similarly. Whether or not you do it that way or the less recommended way of just kind of pasting it in here, because it doesn't matter if someone steals your key because maybe you're on a free tier. Either way, we do recommend that you take the time to register these keys. So for the sake of Alchemy, they operate RPC endpoints that you can connect to. They can all be forked, and they provide a great developer experience. And for the sake of Arbiscan, they'll give you 5 API calls per second, which should be more than enough. This is very useful because all the contract source codes generally find their way to being uploaded to Arbiscan or for Ethereum Etherscan. And if you don't want to mess around with pulling the APIs yourself, you can just download them directly from all these relevant block explorers. So with that, and we've pasted the factory address in here, let's get to work. The first thing to know is just simply how to set up your local Boa environment to work against a forked RPC node. And as we mentioned, it's very easy. The Titanoboa documentation, available at titanoboa.readthedocs.io, will include a lot of good information, but as you'll see, the Titanoboa progress is very fast, and even this entry is already out of date, which we'll show off in just a second. But the relevant section of boa.env.fork, the URL, that's all the same. So if you go ahead and replace this with boa.env.fork and pass in the RPC URL, we should see that the current block number, in fact, updates. This is the part that's different. You might notice that it's no longer using the exact same command. If we actually try and copy the command that's in the documentation here, you will see that it is, in fact, out of date. So this has been renamed. There's good reason for it on the developer side of things, so you can read through the developer commits to understand the madness behind their methods. But the important thing is that it's now including these patches, which only some of which exist. You could actually contribute here yourself. If you learn to read through the Titanoboa source code, you'll be richly rewarded in terms of the understanding of how it actually works. So here's fork RPC, and here's where we pull in the block number from these patches, which we'll cover in a future video. As you can see, we're connected. So with our connection, we're going to go ahead and redo everything we did in the first video. We've, again, not recovered this. You can go back and watch through the prior video. But we've deployed a meme coin, which we'll be using in future units. And you can see that it is now being deployed against a actual forked copy of the mainnet. So the final thing we need to do is we need to load the Llama Land factory. So if this cell executes properly, you'll actually be reading live blockchain data. Right now, there's 9 Llama Land markets on Arbitrum. By the end of the next video, that will increment by 1 because we'll be deploying 1 to it. But first, we need to learn how to load a factory. So this also exists within the Titanoboa documentation. The command is pretty simple, boa.from-etherscan. By default, it's going to be set up to ignore some of these other parameters other than the contract address. But we want to pass them all because this is not going to be working against etherscan. This is going to be working against arbiscan. So we're going to do a simple boa.from-etherscan. One of the reasons that people like Jupyter Notebooks is if you click Shift-Tab on it, it's going to actually read doc strings or relevant documentation about this this function that we were able to call. So we see that we are able to pass the factory address from above. Following that, we need the name, which we'll call factory. We need the arbiscan API address and the arbiscan key, and we should be off to the races. Indeed, you can see there are 9 llama-len markets on Arbitrum, but if you stay tuned for the next video in the series, there will be 10 llama-len markets on this forked version of Arbitrum. Stay tuned.